All right, so we are doing a quick little mini lesson review on exponential growth and decay, and we're going to start by writing the multiplier value for each of these situations. Now that multiplier, remember, is the b value in that equation for exponential growth and decay, y equals a times b to the x. So in letter A here, the number of spiders in your house triples every year. That means we're multiplying by 3, so our b value would be 3 there. Half of the mashed potatoes get eaten every hour. We're losing half or retaining half. Either way you look at it there, our b value is 1 over 2 or 0.5. Now it starts to get a little trickier in letter C and letter D here. The amount of money in your bank account, it earns 6% interest every year. So I can't just turn 6% into a decimal and call that 0.06 and have that be my answer. 0.06 would not be a good increasing amount because that number is actually less than 1. So what I want to think about is I'm going to keep all of my money. So I'm going to keep 100% of my money, and I'm going to earn an extra 6%. So if I think about keeping 100% and earning another 6%, well, 100% written as a decimal is just the number 1. So I really have 1 plus my additional 0.06% or 1.06 as my multiplier. Now that number is greater than 1, so I know it's growing. It's like 106%. All of my 100% of my money plus another 6%. Letter D, a little bit different. Now our car is depreciating or losing 13% of its value every year. So now I have 100% of the value of my car minus the 13% that it's depreciating. So 100 minus 13, we're looking at 87% we're holding on to now as a decimal, 0.87. So just because I'm losing 13% doesn't mean that my rate is going to be 0.13, right? That would be if I'm retaining 13%. In this case, I'm holding on to 87% or losing 13%. So my rate would be 0.87. That's going to come into play, both of those, in our examples here coming up. Quick little review on our exponential growth and decay equation. Y equals a times b to the x. A, remember, is like our y-intercept or starting value, and b is that multiplier. Special note off to the side here, when that b value is greater than 1, we've got growth. When that b value is less than 1, but greater than 0 still, it'd be a situation of exponential decay. All right, so let's look at a couple examples here. Mr. Smith invests $950 in an account that earns roughly 8% interest each year. Is this growth or decay? We know this is growth because of that word right there, earns, right? We're earning money. That money is going up, it's increasing, so it's definitely growth. What is the multiplier? Well, we're earning 8%, so remember you're keeping 100% of your money, all of it, plus another 8%. That's 108% written as a decimal, 1.08. So write an equation to describe how much money Mr. Smith will have after X years. We've got our beginning value, which from the problem up above is 950, times our growth rate or multiplier, 1.08, all to the X. So there's our equation there. How much money will he have in 7 years? I know that 7 years is a time value. That's my input. That's going to go in for x. So we should get y equals 950 times 1.08 to the 7th power. Now, when you enter that in your calculator, you can enter it literally as it's written there. So just write out 950 parentheses 1.07, and then you might, 1.08. Then you might have to hit a little caret button, right? A caret and then a 7 gives you the exponent there. So when I type that into my calculator and I hit enter, I get approximately $1,628.13 rounded to the nearest cent there. If you need help inputting that into your calculator, make sure to ask a teacher or a friend in class. All right, now we've got a little different situation. The value of Miss Bimji's collection of cat posters, currently valued at $846, depreciates by 13% each year. I know that this is going to be a decay model because it's depreciating, and that word means losing value. So we're going to be going downwards here. It's a shame for Miss Bimji. What is our multiplier or B value? Well, remember, we want to keep 100% of our value except for the 13% that we're losing. So 100% minus 13%, that is 87%, or 0.87 as our multiplier. All right, so now we got to write our equation. Well, we have y equals our starting value, which I believe was up here, 846, times our multiplier of 0.87, all to the x power. All right, so now we can figure out how much money her collection will be worth at any time frame in this specific next question. How about after 12 years? So our y value is going to just stay as y since we don't know how much money it's worth. So 846 times 0.87 now to the 12th power. When I type that in my calculator exactly as it's written there, 846 parentheses 0.87 to the 12th. She's lost a lot of value in this, and I get y equals approximately $159.07. All right, there you have it. Quick review on exponential growth and decay with percentages. If you have any questions, make sure to ask your teacher or someone in class.